This segment, what I want to look at is the rules for electrostatics and how objects can become charged. First rule, most important rule, is that only the electrons move, or negative charges move. Right? The positive charges that come from the protons are locked inside the nucleus of the object. Second rule is that opposite charges, whether you've got a positive and a negative, those objects will be attracted to each other. Like charges, so if you have a positive object and a positively charged object, or a negatively charged object and a negatively charged object, they are going to be repelled away from each other. And the third rule is that charged objects, whether they're positive or negative, are always attracted to neutral objects. Let me show you a little animation that basically goes over all three of these rules very nicely. So what I have here are three neutral objects. I've got a sweater, and it is neutral because it has an equal number of positive and negative charges. I've got a balloon, equal number of positive and negatives, and this wall, equal number of positive and negatives. Each one of these are neutral. When I bring this balloon over to the sweater, I'm going to rub it against it. Just like John Travolta rubbing his foot against the carpet, the balloon's going to pick up a negative charge. So now the balloon is negatively charged, and the sweater is actually positively charged because it lost the negative charges there. Now I'm going to bring this balloon that's negatively charged to this neutral wall, and look what happens to the charge on the wall. Okay? Like rule number 2 said, is that the negative charges, or the like charges, are going to repel. So the negative charges on this balloon are repelled away from the negative charges on the wall. And also, look what didn't move. Positive charges, they don't move. Now why is it sticky? Well, these opposite charges of the positives from the wall are attracted to the negatives of the balloon, and that's why it's being stuck to the wall. So we break this down. We've got this negatively charged balloon and the neutral wall, equal number of positive and negatives. Well, the negatives migrated away because they wanted to get away from the negatives on this balloon when it got brought near it. So now what will happen is the positives are close to the wall, the edge of the wall, and there's this attractive force going on there, and the negatives are over here. Now notice the wall is still neutral, it just redistributed the negative charges in order for the positives to be attracted to the negatively charged balloon. Right. Now, how is charge transferred? Electrons may be transferred from one object to another. If an object loses electrons, negative charge, it becomes positively charged. This is like the sweater that I just showed you in that animation. It lost the negative charges that it had on it, now making it positively charged. If an object gains electrons, like the balloon, it then becomes negatively charged. And if an object has an equal number of protons and neutrons, it is neutral. Okay? So neutral objects have an overall net charge of 0, but it doesn't mean that they have no charge at all. There's just an equal number, and that's why it's neutral. Now let's look at the law of conservation of charge. The law of conservation of charge says that the total charge of a system remains constant. When objects come in contact with each other, the total charge is evenly distributed between them. Let's look at these two spheres I have here. Let's call this sphere A. I'm going to give this a negative 4 coulombs of charge. And sphere B has a charge of positive 2 coulombs. So the total charge, or the net charge, before these come in contact, just adding these two together, I get negative 2 coulombs. Now the total charge, after they come in contact, still has to be negative 2 coulombs. However, when they come in contact, the charge is evenly distributed between them. So I'm going to take this total charge of 2 coulombs, divide it by the number of objects that come in contact, in this case just 2. So now, they'll each have a charge of negative 1 coulombs, keeping the total charge in the system constant. Adding these two together, I still get a total charge of -2 coulombs. Let's look at the difference between conductors and insulators and why certain materials conduct electricity better than others. Conductors are materials that allow charges or electrons to move easily through them, or just easily within them. Let's look at this animation here. Okay. If I look, I've got this negatively charged object being brought to this neutral conductor. Okay, it's neutral because you can see before the charges are moving that there's an equal number of positive and negative charges. However, you notice that the negative charges are easily moving around in the object. Positives, as we said earlier, remain stationary. Some examples with this would be like copper, gold, and aluminum. Metals are traditionally good conductors of electricity, and it really deals with the bonding that goes on, the metallic bonding. If you remember from chemistry, these atoms are bonded because of the freely moving electrons. That's why they're good conductors of electricity. Insulators, on the other hand, are materials that do not allow charges to move easily in them. So if we look at this animation here of an insulator, right, it's neutral. I'm bringing this negatively charged object near it. However, the negative charges do migrate a little bit, but they just don't move nearly as easily as the conductor did. Okay, they're still kind of hovering around the positive charge that they're in there. Okay. Examples of insulators: glass, wood, and most plastics. And again, the reason why insulators are good do not allow the charge to move easily through them, is because the way that the electrons are bonded in the atoms, the molecules. Now let's look at ways to actually charge an object. First and easiest way to charge an object is through conduction. And this is charging a neutral object by contact. See the word conduction, and then this begins with contact. Okay. So take a neutral object, have it in contact with a charged object, and it becomes charged. Now the neutral object always gains the same charge compared to the charged object. So if we look at this animation here, or a picture rather, I've got this neutral metal sphere. The negatively charged rod is brought near the neutral sphere, and it jumps over to it. And now these electrons, negative charges, jump over to this metal sphere, redistribute themselves, and you can see that this is now charges negative. Okay? Look at this animation that kind of shows it and breaks it down. So I've got this neutral object to begin with right now. The negative object gets brought down. The negatives jump to it. Now if you kind of look at it, the negatives that were on this migrate down here, getting away from those negatives, and these negatives are attracted to the positives that are at the top. Now, so this took in electrons, so now it's negatively charged. Right? How you get something to be positively charged? We've got to lose electrons. So I bring this positively charged object near this device. The negatives migrate towards the top. Once we have conduction, they can literally jump onto that object, and now lost electrons, making it positively charged. The second way of charging an object is through induction. And this is charging an object without contact by allowing the negative charges to move either on or off a neutral object. It's a little bit trickier to visualize what's going on here. Okay? The other thing to keep in mind is that neutral objects gains the opposite charge compared to the charged object that was used. Before I break down this picture here, let me show you a little animation that shows how the charge is moving. Alright, so I've got this device, it's called an electroscope. We'll look at this more in class. But it is neutral originally. And if I was to count the negative positives and negative charges, it would be equal. Now I'm going to bring this positively charged object near it. So when I bring the positive charge object near it, the negatives, which are the only things that are allowed to move, are attracted to it. So they migrate up to the top of this device, electroscope. Right? Now, what we're going to introduce is a grounding wire. A grounding wire can just pull off or dump charges into a big bath of neutral objects. So it's literally like the ground. Right? Now, what will happen in this particular case is that there's positive and negative charges over here from the ground. By using this wire, it can even pull more negative charges onto this electroscope because it's attracted to the positives here and also to the positives from the object that I'm bringing near the electroscope. So negatives will migrate onto this. So it's picking up negatives, and because it's adding negative charges, it becomes negatively charged. Okay? The entire time, the positively charged object never touched the electroscope. Let's look at this, and it's kind of the opposite, these pictures here. So we're bringing in a negative a negative rod near this neutral sphere. Okay? What happened here was that the negatives were repelled away. The negatives were originally right here. The positives are going to remain stationary, but the negatives migrate away. So now we have all these negatives built up on this side. They want to get away as far as possible, but as far as possible right now is just the opposite side. We introduce a grounding wire, and now there's like an escape route. So as electrons move off the sphere. You can almost think of it like this is a fire in a room, and the people in the room are the electrons. They're the ones that are free to move, and the positive charges are the chairs. They can't move. Well, the people want to get as far away from the fire as possible, so they migrate to the other side of the room. Well, it's a locked room, so they can't get out. All of a sudden, a door breaks open, and they can rush out. So all the negatives leave the room, leaving only the positive charges of the chairs behind, making the overall object positively charged. Opposite charge of the rod, the object that I used to actually charge it with.